Good morning and happy Friday, my people. I know that we've been having a little issue with signing in and submitting this assignment, so I'm going to make a little how-to video real quick that you guys can follow, and hopefully this will be helpful for the future too. I made myself a student account so that I can see what the class looks like from your perspective and make sure that everything works and that my submissions make sense. So I'm going to show you how I'm going to log in and submit this assignment. So you'll see here that on this class for Mr. Andrews, it is due Monday, or due Monday is this assignment that I put up today. So I'm going to go in here, upcoming, due Monday, thermodynamics review. So I'm going to click this review. There we go. So I put my directions that we can see here. And you'll notice that in part 3 here, it says the exit ticket is what I want turned in. The slides and the page here, um, you can download and make a copy of those for yourself. You can open up, you can look at them, you can print them out, but you can't edit them. You're going to have to make a copy of those if you want to edit them. And I did that intentionally so that you can look at them, you can download them, you can do what you want with them, but what you need to submit is up here where it says your work. So I'm going to click on this, and it says Luke Andrews because I'm playing as a student named Luke Andrews right now. So question, it's a lot like one of the review questions from the review page, the review packet. Draw a heat reaction curve for a spontaneous reaction whose reactants have potential energy of 150 kilojoules and activation energy of 50 kilojoules, and whose products have a potential energy of 75 kilojoules. So I'm going to use the scribble tool. If you go up here, select scribble. It will be maybe in a little different place on a phone or a tablet, but it'll honestly be probably easier to draw on a phone or tablet. So reactants have a potential energy of 150 kilojoules, and they have a 50 kilojoule activation energy, which means my curve would go up to 200, and then down to my products with a potential energy of 75. So it's a little sloppy, but you get the idea, and when you unclick, it'll clean up the line and make it look a little bit smoother. That's delightful. So over here, there's a text box, but you can still use the same scribble tool and draw, oops, scribble tool, and draw 75. I know it's a little sloppy, but if we want to clean it up, we can. We can just select, clean it, and let me be a little neater this time. 75 kilojoules. It's a little clunky. I'm using a trackpad. It'll be even easier if you do it on a phone, but it's honestly not even that bad. And then down here is because this reaction is spontaneous, the entropy of the system must increase or decrease. Because it is spontaneous, we know that it must release energy and entropy must increase. So I'm going to circle increase, and there, I'm done. And when I'm ready to turn in, I just go back and I click turn in, turn in. Now, when I go and look at this assignment, I can see the assignments that have been turned in, and I can see that file, and I can grade it, and I can give you feedback on it, and it's nice and clean and easy for everybody. So that's what we're going to be doing going forward. Some of the assignments, some will be drawing, some will be writing, but this is generally the format that we're going to be working in. So if there are any questions, please, you can write them in the class comments section down right here, or you can send me a private message right here. All right, guys, thanks for watching. Hope this helps.